Hi class, this is Sir Alex Basco and welcome to our lesson in General Chemistry 2. Today we'll be discussing stoichiometry, which is our lesson 6.3. The goal of today's lesson is for us to be able to perform stoichiometry for reactions in a solution. But before we'll be able to do that, let's first discuss what is stoichiometry. Stoichiometry is basically the quantitative relationship between the number of moles of products and reactants in a chemical reaction. What that simply means is that we're looking for the relationship between the number of moles of substances present in your products and reactants. So products and reactants are basically part of what we call a chemical reaction. Reactants are the substances that you use. These reactants are the substances that you usually combine together or react together. And after they reacted, you usually end up having products. And this is another example of a substance. Okay, so reactants is equals to products. You can think of that as your chemical reaction. And in stoichiometry, you were looking for the relationship of the number of moles of those substances. This number of moles can be a relationship between the reactants or a relationship between the reactants and the products or the relationship between the products. Later I'll explain more, I'll show more what do we mean by that. But let's keep discussing what is stoichiometry in a more layman terms. We can think of it, you can think of stoichiometry as a recipe for a batch of cookies. So let's look at this chocolate chip cookie recipe. In this recipe, it says you would need about a cup of flour, 4 eggs, half a cup of sugar, 1 cup of butter, and half a cup of chocolate chip cookies. Not cookies, chocolate chips. When you add all of these together, you end up having 12 pieces of cookies. So in a chemical equation or in a chemical reaction, you would think all of these right here, this 1 cup of flour, 4 eggs, half a cup of sugar, 1 cup of butter, and half a cup of chocolate chips. You can think of it as your reactants. These are the substances that you combine together, that you react together. In a recipe, we usually call them our ingredients. So you can think of ingredients as your reactants. And then after combining these two together, you add heat. Basically, you bake them in the oven. You end up having 12 cookies. And you can think of these 12 cookies as your products, the result of the combination of your ingredients, or in chemical reaction, the product is the result of the combination of your reactants. So in stoichiometry, what we're looking for is the relationship of the numbers of moles. You can think of the number of moles as in our chocolate chip recipe cookie is this measurement. So like 1 cup, 4 eggs, half a cup, 1 cup of butter, half a cup. You can think of those numbers as the numbers of moles in of these ingredients. But in your chemical equation, you would think of them as the number of moles of the substance. So let's say this flour is an example of a substance. So instead of a cup, we will say mole. So 1 mole of this substance, flour, reacts with 4 moles of another substance, and it reacts with another half moles of another substance, and continue on, and you create about 12 moles of another of your product substance. So I hope that's clear. So that's how we can think of as a stoichiometry. The number of relationship or the number of moles and the relationship between or among the reactants or reactants to the products. Um, let's keep going. It's any more knowledge on stoichiometry. Let's think of it this way. What if I only want 1 cookie? So we know that this recipe here, these ingredients, will create 12 cookies. But what if I only want one? Then how much of each ingredients do I need? So we know that 1 cup of flour, the relationship, it creates 12 cookies. 4 eggs will, after reacting to all of this, will also create 12 cookies. Half a cup of sugar will create 12 cookies. 1 cup of butter will create 12 cookies, and half a cup of chocolate chips will create these 12 cookies. So if I only want one, how much of these ingredients, or you can think of it as the reactants, how much would I remove to create only one product? The answer would simply be we have to divide all of these by 12. So 1 over 12 cup of flour plus 4 over 12 is 1/3 of an egg. Half a cup divided by 12 is basically 1 over 24 cups of sugar. 1 over 12 cups of butter, and again 1 over 24 cups of chocolate chip cookie will react together to only make one cookie. So you basically divide all of them by 12. In chemical reaction, though, we cannot just simply divide all of them. Because sometimes we're looking for grams instead of moles, because in stoichiometry these are in moles. Moreover, what we sometimes look for is grams, or in other words, mass. So we use stoichiometry to figure out the grams of all of these ingredients and products. Okay, so I hope that's a little bit clear. But let's continue in more. How do we perform stoichiometry? Or basically, stoichiometry is what we do in stoichiometry is we measure the chemicals that go into and come out of. So we measure the chemicals, the substance or the reactants that go into are the reactants, and the come out of are basically the products of those reactants at any given reaction. Stoichiometry is basically a Greek word for measuring elements. Stoichiometry is Greek for element, and metron is to measure. Stoichiometry also allows us to count atoms and molecules by weighing them. So count atoms is basically the moles. We can count atoms using moles. And by now you should guys are familiar on how we measure or how we find moles. To find moles, we usually use the mass of the substance divided by the molar mass. Let me just write that. So we should know by now that to measure moles, we usually have to have the mass, and usually in grams, of the element or a substance, and we have to divide it by molar mass. We've discussed this when we were talking about the concentration of solutions. And in stoichiometry, we usually use moles. But in the end, we can also use this relationship of moles and mass and molar mass to find the grams or the mass of the substance. So that's the use of stoichiometry. And in stoichiometry, one thing that is very crucial is to understand how to balance an equation. Why is that? It's because it gives us the mole ratio, which is the relationship between the amounts of moles of substances in your reaction. Remember, stoichiometry is the relationship of the number of moles of the substances, and we get those relationship via mole ratio. Let's see what do we mean by that. So let's take this as our example. So this is our chemical equation. We know that Fe2O3, when it reacts to aluminum, it creates uh, a liquid iron plus an Al2O3 solid. So you can think of this again as your reactants. So these are your reactants. And after they react together, they create your product. So in this scenario now, as you can see, the equation is not balanced because in your reactants, you have two atoms of iron, but in your equation, you only have one atom of iron. And in here, you have on your reactants, you only have one atom of aluminum, while you have two atoms of aluminum in your product. So how should we be able to what we call this? How can we balance this equation so that we have an equal amount of atoms of iron and aluminum on your reactants compared to the number of atoms of iron and aluminum in your product? What we can do is by writing coefficients. So basically in this case, we know that we need two iron because for in products because we have two atoms of iron in our reactant. So what we can do is we can basically write two in front of iron on your product. This means that we have two atom of iron here, which balances out because in here in our reactants we have two atoms of irons as well. Now next, we in our products we have two atoms of aluminum. So in here, what we can do is we can basically also write two in front, a coefficient of two in our aluminum, which means in our reactant we have now two atoms of aluminum, which is equal to two atoms of aluminum in our product. So looking at all the number of atoms for all the elements, we can see that everything is balanced. So now that we were able to balance our equation, let's discuss what is mole ratio. So mole ratio is basically the relationship of number of moles between substances. So in this case, we can create a mole ratio between between your reactants. So let's think of it this way. So the mole ratio between our reactants is that we need 1 mole of Fe2O3 to react to 2 moles of aluminum. We can also create a mole ratio. So these are mole ratio. This is the relationship of the number of moles between your substances. We can also create a mole ratio between the substances in your products. We know that our product results in 2 moles of iron to 1 mole of Al2O3. And in a third way that we can create a mole ratio is by our reactants and products. An example here is that we know that 1 mole of Fe2O3 can create 1 mole of Al2O3. You can also write it as 1 mole of Fe2O3 to 2 moles of Fe. Or another way that we can write this is in our products, 2 moles of aluminum can create 2 moles of iron. So this is the way that we can create mole ratio between between reactants, and even between reactants and products. So you can create a mole relationship between the Fe2O3 to Fe to the aluminum to Al2O3. So there's different ways to aluminum to iron, or these two to that. So those are what we call the mole ratio, and we at in solving stoichiometry problems. So, how to perform stoichiometry? First, we have to make sure that your chemical equation is balanced. Again, this is important. It's because that's when we get our mole ratio. That's where we can find the relationship between the reactants, between the products, or between the reactants and the products. The mole number relationship. And then the step one that you have to do is to convert the mass or the volume of your known, which is usually the given substances, to moles. We begin, this is very crucial, this is a general step. We begin by first converting the mass or the volume of your known substance into moles. So we begin by converting the mass or the volume to moles. The second step is to, using the mole ratio obtained on your balanced chemical equation, find the mole of the substance you are looking for. So after we find the moles, we have to use the mole ratio created by balancing your equation. I'll show you how to do that in a minute. And then in step 3, after finding the mole of the substance you are looking for, you get that by using the mole ratio. You can then convert the mole back to mass or even volume, whatever the question is looking for. Take note that sometimes it is quite necessary to use your understanding of concentration, more specifically molarity. You guys remember the molarity is basically moles divided by moles of a substance divided by liters. Or even sometimes you have to use molality, which is moles per kilogram of solvent, liters of solution. Okay, so sometimes you have to use this relationship as well to find moles. But let's remember these steps as we go on to our sample problems. Let's begin the problem here. So how many grams of NaOH are required to fully consume 3.10 grams of H2SO4? Okay, so first crucial step that we have to do is first to balance our equation. So let's check if our equation is balanced. So in this case, we have on our reactants, we have 1 atom of sodium, and here we have 2 atoms of sodium. So meaning we have to balance our sodium. Next, let's see how many atoms of oxygen we have. We have basically 5 atoms of oxygen in our reactants, and in here we have 5 atoms of oxygen in our product. So for oxygens, it is balanced. As for hydrogen, in here we have 1 atom of hydrogen plus 2 atoms of hydrogen. So basically we have 3 atoms of hydrogen in our reactants. However, in here we have only 2 atoms of hydrogen in our product. So meaning our hydrogen is not balanced. For our S, we can see that our sulfur is balanced because we only have 1 atom of each on both products and reactants. So how can we balance this equation? Basically, what we're only missing is 2 atoms of sodium, and here we need 1 more atom of hydrogen in our what we call this, in our product. Okay, so the way that we can balance this is we can write 2 as a coefficient on here, which means we have 2 atoms of sodium, 2 atoms of oxygen now, and 2 atoms of hydrogen. So we were able to balance our sodium. But now look that we have two atoms of oxygen here and other atoms of oxygen here, so our oxygen is also not balanced anymore. We need one more, or yeah, so we need one more oxygen in this side. So what we can do to balance that is basically add 2 here. So this way we have 2 atoms of oxygen here plus 4 atoms of oxygen, so that gives us 6 atoms of oxygen, and this gives us a total of 4 hydrogens, which is the total number of hydrogens on our reactants. So in this way, our equation is now, chemical equation is now balanced. Okay, so now after balancing our equation, so the first thing that we can do now is first let's write our given before using the steps. So here they give us 3.10 grams of H2SO4, and what they're asking is how many grams of NaOH is required to fully consume H2SO4. So what that means is I'm looking how much grams of NaOH do I need to react or to combine with H2SO4 to create my products. So that is basically the question. And what we can do is basically the stoichiometry. So let's immediately go on the solution. Okay, so remember our step 1 is first uh, change our grams or volume to moles. And in this case, our given is 3.10 grams of H2SO4. So this is our given. We have to change this grams of H2SO4 to moles of H2SO4. Since they did not give us the molar mass, I hope you guys are familiar now how to get the molar mass. So it's basically getting the molecular weight of H, S, and O4. So basically, the molar mass of H2SO4 is actually 98.08 grams per mole. So if you guys do not remember how to get the molar mass of a substance, you guys can go back to the previous lesson. So using this molar mass now, we can get the moles of H2SO4. So basically, we have to multiply 3.10 grams of H2SO4 to 1 mole over 98.08 grams. And that gives us actually about 3.16 times 10 raised to negative 2 moles of H2SO4. Then let's go to our step 2. In our step 2, we have to use the mole ratio. And in this case, because of the question, what we are looking for is the mole ratio between the two reactants, because you're looking for the grams of NaOH and H2SO4, and these are both part of your reactants. And from balancing the equation, we know that the mole ratio is 2 moles of NaOH actually reacts to 1 mole of H2SO4. Now we can use this relationship now to find the moles of NaOH, because we found the moles of H2SO4 here, and we are looking for the grams of NaOH. So we have to look for first the moles of NaOH. So what we can do is, um, sorry, start with the moles of H2SO4 that we found, which is 3.16 times 10 raised to 2 moles of H2SO4, and then we have to multiply it by 1 mole of H2SO4 is equal to about 2 moles of NaOH. Okay, so yeah, so this is it. Um, we can cancel this now, we can cancel this. Then we have to multiply this, which gives us about 6.32 times 10 raised to negative 2 moles of NaOH. So we got this via understanding that we have the relationship between the moles of these two substances from balancing your equation. So it's basically a conversion. It's basically just conversion. So after looking for the moles, the given moles, we multiply that given moles to the mole ratio from your balance equation to get the moles of the substance you are looking for. And step 3 is to convert the moles of the substance that you finally found to its uh, mass or volume. In this case, mass, because they're asking for the mass of NaOH. So 6.32 times 10 raised to 2 moles of NaOH. And we can do this by again getting the molar mass of NaOH. So what is the molar mass of NaOH? The molar mass of NaOH is about 40.00 grams per mole. So I hope you guys know how to get the molar mass. Again, it's in the previous lesson. So that means is 40 grams on top divided by 1 mole. And from there, we can cancel mole and multiply 6.32 times 10 raised to negative 2 to 40 grams. And that would give us about 2.53 grams of NaOH. So this is our final product. Okay, what does that mean is that in order to fully consume 3.10 grams of H2SO4, we need about 5.53 grams of NaOH. By combining this amount of NaOH to this amount of H2SO4, there will be no excess. You can think of it as the 1 cup of flour to the 4 eggs on your 4 eggs on your cookie recipe, and that 1 cup of flour and 4 eggs creates 12 cookies. In this case, there is no excess because you found enough grams of NaOH to react to all the grams of H2SO4 to create these products. Okay, so I hope that's clear on how to perform stoichiometry. This time let's try it again and on another sample problem. Okay, so here, um, calculate the mass in grams of calcium nitrate or CaNO3 2 that can be produced by reacting to 136 ml of 4 mol 4 mol molal molar 4 molar of nitric acid with excess calcium hydroxide or CaH2. The molar mass of calcium nitrate is 164.10 grams per mole. Okay, so how are we going to solve this? Okay, let's begin by writing our given. Okay, so our given is first they gave us the volume. Can be produced by reacting to 136. So they gave us 136 milliliters of HNO3 or citric acid. Next, they also gave us the molarity. So we have about 4 moles of, which is 4 moles of nitric acid. Okay, and then in here they also gave us the molar mass of CaNO3 2, which is 164.10 grams per mole. Okay, so what are they asking us? One here, there it says calculate the mass. So we know that it's looking for grams, but which grams? Calculate the mass of calcium nitrate. So we're looking for the grams of calcium nitrate that can be produced. So from this wording itself, that can be produced by reacting 136 ml of 4 moles of nitric acid with calcium hydroxide. So from this wording itself, this is actually your product. And HNO3 is one of your reactant, or this is your ingredient. So we are looking for how many grams of nitric or calcium nitrate can be produced by reacting HNO3 to calcium hydroxide, which is CaOH2. Okay, so let's begin by first balancing your equation. So we have to write the equation. Okay, so we know that one of our products is HNO3. And it reacts with calcium hydroxide, which is CaOH2. And we know that one of the product is actually Ca and O3 2 plus, so in this case you would actually end up with H2O because you have Ca here and you have NO3 here, and you end up with OH and H, which is basically H2O. So balancing your equation now, you would see that here NO3 you have 2 atoms of NO3, but you only have 1 atom of NO3 here. It means you need 2 more NO3 here. So that gives you 2 atoms of NO3, 2 atoms of NO3, that checks out. But in here, now you have 2 atoms of hydrogen. So what you need is basically adding 2 on this side. So you have 2 atoms of hydrogen, another 2 atoms of hydrogen here, that gives you 4 hydrogen. Here you have 2 atoms of hydrogen multiplied by 2, that's 4 atoms of hydrogen. Okay, same thing. You have, so I think that is, yeah, that is, I think is balance. Okay. Yeah, so that is balanced because you have 2 oxygen here and another 2 and oxygen here. So, okay, so you have now your balanced equation. Let's go for the solution. So we begin by converting our grams or volume of our given to moles. In this scenario, they give you the volume. So we're not dealing with grams, we're dealing with volume. And we have to change it into moles. In this scenario, we cannot use the typical mass over molar mass. That is because we don't have a mass, we have a volume. But what we can use is molarity, because they also gave us molarity. Remember, molarity is moles of substance divided by the liters of solution. So they gave you the liters of solution and they gave you the molarity. So you can actually use that to solve for the moles of your substance. But first, let's change our 136 to liters. Okay, so we'll begin by changing 136 ml, which is about 1000 ml to 1 liter, and that gives us 0.136 liters. And now we can use molarity to find the moles. So since we're looking for moles, moles is basically equal to molarity multiplied by the liters, which is, the molarity is 4 and the liters is 0.136, and that gives us the moles is equal to about 0.5440 moles of HNO3. Okay, next we have to use mole ratio. So which mole ratio are we going to use? In this case, they're asking for the product, and they gave us given on the reactant. So we have to find the relationship between your product CaNO3 to your reactant HNO3. And from your balanced equation, you see that you need 2 moles of HNO3 to create 1 mole of CaNO3 So you can use that equation to find the moles of CaNO3. So you'll begin by using the mole that you figure out on your number 1, which is 0.5440 moles of HNO3, and then you have to multiply it by the mole ratio between the two. You know that you need about 2 moles of HNO3 to create 1 mole of CaNO3. And canceling this. So again, you got this from your balance equation. This is the mole ratio. And from multiplying this, you actually get about 0.27220 moles of CaNO3. Okay, and on the third, you have to convert these moles now into, in this scenario, you were looking for grams. Okay, so in order to do that, you have to use mass per mm, or the mass per molar mass. So about 0.2720 moles multiplied by, from here you were given that the molar mass of CaNO3 is actually 164.10 grams per mole. So 1 mole at the bottom and 164.10 grams. From there you'll get that the grams of Ca or calcium nitrate that you need is actually about 44.46 grams CaNO3. So that is the amount of nitric acid or calcium nitrate produced from reacting nitric acid and calcium hydroxide. So this is the amount of product. Okay, I hope that is clear. Let's try the last one, and how to perform stoichiometry. Okay, so let's begin by writing our given. So how many liters? So we have a liters of 0.43. So again, this M, they gave you the molar. So this is, you see that there is molarity going on here. It's required to neutralize 0.78 grams of sodium carbonate. Okay, so what you're looking for is how many liters of HCl do you need to neutralize 0.78 grams of sodium carbonate. Okay, so you basically have acid and salt. Okay, so let's write our given. So first they gave us the molarity of HCl. And we know that the molarity is H 0.53 molar. So this capital M is molar. That's 0.53 molar. They also gave you the grams of Na2CO3, sodium carbonate. And that is 0.78 grams. And they also gave you the molar mass of sodium carbonate, which is NaCO3, which is equal to 105.99 grams per mole. So this is NaCO3. Okay, so what are they asking you? How many liters of HCl is required? So they're looking for the liters of HCl. Okay, so let's go on our balancing equation. So basically you are reacting HCl and Na2CO3. So you basically given two what do you call this, two reactants. Okay, so they gave you HCl reacting to Na2CO3, sodium carbonate. And by actually reacting acid and base, or yeah, acid and base, you should be able to get salt 2 or NaCl, and HCO3. In this case, it should be NHH2CO3. Okay, so now let's look on our equation. Let's try balance this. Okay, in our reactants, we have two atoms of Na. We only have one, so we definitely have to have two in front of here, which means we have we have now two atoms of sodium and two atoms of chloride. But here we only have one atoms of chloride in our reactant. So let's write 2 in front as well. Now let's see if our H is balanced. So now we have two atoms of Cl, which is equal to the two atoms of Cl in our product. Now here we have a total of two atoms of hydrogen in our reactant, and also two atoms of hydrogen in our product. So this equation is now balanced. Let's just move it a little closer. So as H2CO3. Okay, so now after balancing the equation, so let's do our solution. Okay, so let's begin on our first step. Let's do it this way. So let's do just a straight one. So our first step is to convert the given grams to moles. In this case, the given grams that we have is the grams of Na2CO3. Okay, we know that about, let's do it here on top. We know that about 0.78 grams of Na2CO3 we need to convert it to moles, and we can do that by using the molar mass. And we know that in molar mass, the molar mass of Na2CO3 is 105.99 grams per mole. So we'll put 105.99 grams here, and this is 1 mole. Okay, so that is done. Next, what we're going to do is number 2, which is use the mole ratio. And the mole ratio that we need is the mole ratio between HCl and between our HCl and NaCO3. And according to our balance equation, we need about 2 atoms or 2 moles of HCl per 1 mole of Na2CO3. Since we begin with Na2CO3, we are looking for HCl. We'll put the HCl on top. So that's 2 moles of HCl. 2 moles of HCl per 1 mole of Na2CO3. Okay. After using the mole ratio, what we need now is to convert the grams of the moles that we found from moles to grams. So we found the moles, and by adding these, we'll be able to find the moles of HCl. In order to change it to grams, we're not looking for grams, we're looking for liters, because it's looking for how many liters. So we have to use molarity, because molarity again is moles per, molarity is equals to moles per liter of solution. So if we're looking for moles, we just have to multiply these two. So what we need to do is we know that 1 liter of 1 liter per the number of moles, which in here they gave us the moles, which is 0.53. 0.53 moles of HCl is equals to 0.53 moles of HCl is equals to 1 liter of 1 liter of this FHCl. Okay, so this part right here is our first part, step 1. Wherein we start with the grams given to us and we have to convert it by moles. We convert it by moles using the molar mass. And this is step number 2. And in step number 2, we use the mole ratio. And step number 3, we change the moles to liter. This can be grams. If this is grams, use molar mass. In this case, since this is liters, we have to use molarity. And by typing that in your calculator, you would actually get about 0.03 liters of HCl. Okay, so that is how we use stoichiometry to find not only the relationship between products and reactants or the substances, but also the amount that you need or the amount that you will get in a chemical reaction. This I hope this can get confusing, but I suggest that you guys go back, try it on your own. It's the same problems, just go back, try it on your own. And if you're stuck, go back on the lecture and study it again. And then afterwards, go back and try and do it on your own and see what you don't understand. And then try to go back on the lecture and try to study it. Try to study the part that you don't understand until you finally get how to do stoichiometry. So just remember this stoichiometry, you need to balance your equation. You need to step 1, which is changing grams to moles. Step 2 is using the molar ratio you got from balancing the equation. And in step 3 is basically after you got the moles of the substance you're looking for, is by changing it to grams or the volume. And if you're changing it to grams, you use molar mass. If you're changing it to volume, use molarity. Okay, I hope this is a little clear. I know this can get a little confusing, but if you guys have any question about this topic, please message me or do not hesitate to message me, okay? And you guys have a great day.